Okay, I'm going to try high-speed steel again. I'm going to put it slow, make it slow. Not the slowest, but we're going to experiment here. I ground a radius on this because I think the problem that I had last time was that the cutting edge was too small. It was this pointy little thing, and I think it just cut right off immediately. So that only cut a little bit, but you know what? I think that's working. So I just slowed it down and made a radius. I'm only doing this because I only have one more of those carbide inserts left. So let's feed in. Let's just do 5 for now. Start things slow. That's pretty good. Alright. So I'm going to keep this going off camera, and I'll bring you back when I get these. It cuts better going back out. And I think that's just because the tool has a chance to lead in a little bit before it takes the full brunt of the cut if I go backwards. Yeah, it's working. I went back to carbide. It's just doing so much better. Alright, so we're ready to do a finish pass here. I've sped up the machine, and I just did a heavier cut, so I'm just going to leave it as a spring pass because I assume that there was some tool pressure there, and I think that should be good enough for a finish pass. So let's see how this turns out. If it doesn't turn out okay, I can just keep going because this dimension here, this thickness, isn't super critical. So here we go. Huh. Alright, I guess I'll feed it in a little bit. How about 2 thou? Oh, we're getting the chatter on the edge like last time. It's the reverse of last time. Maybe I can come back in and do a spring pass, clean that up. Back you guys up here. So you can see this feels nice and smooth, but then out here, again, we're gonna lap it, but still, why don't I slow it down a bit? It's better. Let's keep going. Alright, looking good so far. Looking good so far. Just gotta make it to the end without any chatter. Almost, almost. Nice. Well, let's see what that... Oh yeah. So we just had to get our speed right. Some chips embedded in there. But that is way better. Good. Good. That's just really quick. Gonna hit it with a little bit of emery cloth. Scotch-Brite. There we go, nice and smooth. That feels great. Looks great. Okay, I got my boring bar set up, and I am kind of doubtful that this is going to work because, you know, I just can't see this guy surviving very long. Plus I have a lot of stick out here. So let's just see how this thing behaves. Yeah. I think we're just rounding the bit. Alright, so I was messing around with high speed for a really long time. Couldn't get it to cut. So I found this carbide bit, and that's been working well. So you can see that's cutting pretty well. You can hear the high spots in there thudding. We're getting to that steam port pretty soon, so it might get pretty loud there. Oh, there we go. Going past the steam port. Cool. Well, I'm going to keep this up. I'll bring you guys back when it gets a little closer. Alrighty, let's take a measurement here just to see where we're at. There we go. Let's see here. 1.639. So we still got about 361 thousandths left. Getting a little bit of chatter in there, and we're not all cleaned up yet, but we're getting there. Alrighty, so we're getting pretty close here. I don't normally wear gloves when I do machining, but I kind of have like a important meeting tomorrow, and I need my hands to not be dirty, and I could never seem to get the dirt off without putting in an insane amount of work. So I have gloves on this time, but you're really not supposed to wear gloves. Anyway, we're getting pretty close here. So what I want to do is I want to check how much taper it's cutting, because every lathe is going to have a certain amount of taper. Well, every lathe that has some age is going to have a certain amount of taper that it cuts based on the wear of the bedways. I believe this machine, I think, was built in the I think it was the early 30s. This is an Atlas, but I think it's been reground since then because there are spacers underneath the carriage. So we're gonna see. This machine's usually really good with taper, cutting taper, not cutting taper, I mean. So we're gonna just take a measurement here, and we're gonna see where we're at. So we are at 1 inch 835 thousandths. So now what I'm going to do is I'm going to reach back in as far as I can go, expand this out, tighten it up, and then take a measurement way back there. So let's see here. So this is 834 thousandths. So I'm going to do this a couple more times just to make sure that I have no errors in my measurement since this is a transfer type of measurement, but it's looking like over what is this, 3-inch range. We're cutting like less than 1/1000th taper. So let me just do this again. I just did a couple more times. We're pretty consistent 1/1000 less than over here. So I can't reach all the way to the back and get pretty close, but so we're looking at about maybe a little more than 1/1000th taper from this side to this side after we're done. So that's actually fine, because what I'm going to do is I'm going to get this within just a couple thousandths of 2 inches, which is the bore diameter. And then I'm going to take a cylinder honer and we're going to hone this whole cylinder out to be 2 inches. So what that honing does, at least according to my knowledge, is it gets rid of the machining marks on the surface, and it also provides a nice surface where oil can stick to, because it has that like a crosshatch pattern or whatever. And it's just something you should do for engine cylinders, is hone them, and I have the honer here. So I'm gonna keep going. I'll bring you guys back when I get really close to the edge, but we're pretty much all cleaned up in there. There's just a little spot left from the casting, so I'll see you guys soon. Okay, so I actually ordered a new really nice carbide insert boring bar, and that is in the mail right now, so it's on its way. So what I did was I just got this to 1 inch 900 thousandths. I'm going to do the last 100 thousandths with the new boring bar. However, in the meantime, I can lay out the bolt hole patterns using the lathe. And right now I have one of these center punches in, and so this is just one of those spring back center punches, and I have it in a tool holder, and I'm going to touch off on the side of the cylinder and then back it out to the required diameter. Now I don't want to touch off. I wish I had a more precision punch. With this, I only really have these spring ones, and the problem is that this guy right here wiggles a bit. So I took a measurement of the diameter of the knurled edge right here, and I'm going to use that to touch off since that's not moving. This, it's about a half an inch, is 497 thousandths. So what I'm going to do is, first, let's just color this a little bit so you can see when we're rubbing. So we're just going to do this until we get it. There we go. So right there, it is just rubbing. You probably can't see it, but there's just a little line there that it's hitting. So let's we know that this diameter is 497 thousandths, so we're going to divide that by 2 and back it out that much. 248.5 thousandths. So I'm going to do the best I can. So that's 5, 10, 15, 20, 25, 30, 6, 7, 8 and a half. That brings us right to the edge. Okay, so now we're going to set our 0. So our drawing says that the bolt circle diameter is 3 inch 250 thousandths. Well, half of that is 1 inch 625 thousandths. However, we need to, that is with respect to the very center, okay? We need to now subtract half of the diameter of this hole. This hole now is 1 inch 900 thousandths. So let's see here. So we have 1 inch 900 thousandths divided by 2. That's 950 thousandths. Okay, so that means we have to travel out from this point 675 thousandths. So I've set my 0, and we're going to go 5, 10, 15. Okay, so as a sanity check, I'm just going to bring this up. If we did everything right, we should be about 5/8 from this edge. I know this is a rough casting, but this is just a sanity check. We are pretty much exactly 5/8. Now this is a knot. I'm doing all this work to make this super precise, but it doesn't need to be that critical. You know, plus or minus 5/10 thousandths. The actual holes in the head can be a little bit bigger to account for any, you know, just to add a little bit of wiggle room to where these holes are. So I'm doing the best I can to get it as accurate as I can, but you don't need to be this careful. So now that we have this, we have it set to the proper bolt diameter. So we're going to use the indexer to index this in. Alrighty, so we're at the bull gear in one of these frames, right here, and I have a little mark at the top to indicate which little hole we're looking at. And then on this hole, I'm just going to put a little mark here to show where we started. I have another hole with a mark on it somewhere in the middle, but when that one comes up, just ignore that one. So my bull gear only has 60 holes, right? So I would really like an 8-bolt hole pattern rather than a 6. If it was a 6-bolt hole pattern, it would be really easy. I would just need to divide by 6, and I would get every 10 holes, put a little mark. However, I really want an 8, so that makes it 7.5, and this is kind of the reason why I was being so careful for everything, is because this step is going to have the most error in it. Again, it's not going to be a big deal because the bolt holes on the head are going to be a little bit bigger than the actual shaft of the bolt, so there will be enough room for wiggle room. So I need to go every 7.5 holes. That presents its own challenge because I have to now stop in the middle of 2 holes. So we're going to start here. So let's see here, we're going to move this guy up, and there we go. We have a little divot where our first bolt's going to go. Next, we're now going to move. I'm going to try to stay out of the camera's way. We're going to move 7.5. Okay, so 1, 2, 3, 4, 5, 6, 7, and then we're going to go half of 1 right there. So we're going to make another little hole. Okay, then we're going to go another 7.5. So let's do the 5 first, or the 0.5 first. So 0.5, and then 1, 2, 3, 4, 5, 6, 7, a little more. So that is the next one. I'm going to put a little divot. You know, worst comes to worst, if I mess up, I can just face this off again. It'll be a little smaller than I want it, but that's not a big deal. So, let's go another 7.5. And now, here's the moment of truth. Do we come back to where we started? 0.5. 1, 2, 3, 4, 5, 6, 7. We are back to where we started on the bull gear. And this guy fits exactly where he started in the first place. Alright, so now we have a 8 bolt hole pattern all notched out, and it'll be really easy to drill these holes in the drill press because it'll just go right into the divots.